Conway's Doomsday algorithm for calendar calculations. First of all, what is a doomsday? Contrary to its most common usage, doomsday in this context refers to certain dates in a year which always fall on the same day. There are a few particular easy-to-remember doomsdays. January 3rd for regular years, or January 4th for leap years, the last day of February, April 4th, May 9th, June 6th, July 11th, August 8th, September 5th, October 10th, November 7th, and December 12th. Some of them, like April 4th and June 6th, are very easy to remember. However, there are a few tricks for other dates. For May 9th and July 11th, this simple phrase aids with memorization. I work 5-9 at the 7-Eleven. The reverses of these dates, 9-5 and 11-7, are also doomsdays. For January 4th, doomsday falls on the 4th of every 4th year. There are 3 integral steps to finding the day of the week for any given date. First, determine the century's anchor date. Second, calculate the day of the week of the year's doomsday. Third, count the number of days modulo 7 between the given date and the closest doomsday, and determine the day of the week. For the sake of understanding, we will be going through these steps out of order. So, how do you calculate the day of the week for any day in a single year? Suppose we know the day of the week of Doomsday. How do we do calendar calculations within that year? First, determine if the year is a leap year or not. Keep this in mind when choosing the Doomsday dates and when counting the number of days from Doomsday. Then determine the Doomsday which falls closest to the date being calculated. There is a Doomsday for every month except March, so the closest Doomsday should be relatively close by. Next, count the number of days between your date and the Doomsday date. Take this number modulo 7 and advance the Doomsday date of the week this number of days to determine the day of the week for your date. For this step, it may help to think of the days of the week as so. Sunday is O day, Monday is 1 day, Tuesday is 2 day, all the way to Saturday is 6 day. Here is an example. Suppose we want to calculate the day of the week for February 24th, 2016. We know the Doomsday for 2016 is Monday from this handy chart here. The closest Doomsday is the last day of February. Because 2016 is a leap year, this day is February 29th, 2016. February 24th is 5 days before February 29th, which can be thought of as -5 modulo 7, which is congruent to 2. Hence, advance the Doomsday date 1 day, or Monday, 2 days forward to 3 day, or Wednesday. Therefore, February 24th, 2016 falls on a Wednesday. This part of the algorithm is pretty intuitive. A week is 7 days long, so every 7th day is the same day of the week. So when is Doomsday? Now suppose we don't have our handy chart from before, and we must calculate the day which Doomsday falls upon by hand, according to the year. How is this accomplished? There is a formula for calculating the day of the week that Doomsday falls on. As you can see, there is something called the anchor in this formula. We'll go over the anchor later, but it is a number associated with each century. Here's an example of how to use this formula. Let's calculate the Doomsday for this year, 2017. Suppose we know that the anchor for this century is Tuesday. As we can see, 2017's Doomsday falls on a Tuesday. Now let's check this calculation with an actual calendar of this year. The closest Doomsday to today is April 4th, and April 4th falls on a Tuesday, so our calculation was correct. Of course, this formula can be slow or difficult for a mental calculation because there are so many elements to deal with. Fortunately, Chamberlain Fong and Michael K. Walters developed another method to calculate a year's Doomsday. First, take the last 2 digits of the year in question. If they are odd, add 11. Divide the resulting number by 2. If the resulting number is odd, add 11. Take the resulting number modulo 7 and count that number of days backwards from the anchor day. Here's an example, again involving the year 2017. The last digit 17 is odd, so we add 11. Then we divide by 2. This number isn't odd, so we leave it alone. 14 modulo 7 is congruent to 0. The anchor day is Tuesday, so the Doomsday for 2017 also falls on a Tuesday. This is the same result as we determined before, and is correct according to the calendar. Now what is the anchor day? As you saw before, the calculation for Doomsday involves an anchor day. Simply put, the anchor day is merely the day of the week of the Doomsday of the first year in a century, so 1800, 1900, 2000, etc. Now, there does exist a formula to calculate a century's anchor day. Thus, for the century 1900, the anchor day is 5 times 19 modulo 4 modulo 7 plus Tuesday, which is congruent to 15 plus Tuesday, which is congruent to 1 plus Tuesday, which is Wednesday. So why does this formula work? This formula actually depends on the rules for determining a leap year. Leap years are divisible by 4, except when they are divisible by 100, but they are leap years if divisible by 400. Thus, the Gregorian calendar makes a full cycle every 400 years, and the calendar is identical every 400th year. This explains the term year over 100 modulo 4. The term Tuesday simply means that when the year is divisible by 400, the anchor day is Tuesday. So what's up with the 5 and the mod 7 then? This is based on the first two rules for leap years. Leap years, having 366, which is congruent to 2 modulo 7 days, advance the calendar by 2 days, and regular years advance it by 1. In a given century, there are 24 leap years and 76 regular years, so the total number of days advanced in a century is 24 times 2, plus 76 times 1, which is congruent to 5 modulo 7. Thus, for every century, excluding centuries divisible by 400, the days of the week are advanced 5 days. Centuries divisible by 400 advance the calendar by 6 days. However, when you're trying to do calendar calculations quickly, like Conway himself, who takes about 2 seconds using his method, this formula becomes a bit cumbersome. Fortunately, there is a more algorithmic way to go about determining the anchor day that requires a little memorization. So suppose R is the first 2 digits of the year, modulo 4. If R equals 0, the anchor day is Tuesday. If R is 1, the anchor day is Sunday. If R is 2, the anchor day is Friday. If R is 3, the anchor day is Wednesday. This quick little method can easily be proven by checking the formula 5R mod 7 plus Tuesday equals anchor from before. Up to now, we've been focusing on doing calendar calculations for the Gregorian calendar only. However, what if we want to determine the day of the week of some day that falls in the time when the Julian calendar was used? We must make a few minor alterations to the previously established Gregorian calendar rules. First, a brief explanation about how the Julian calendar works. Unlike the Gregorian calendar, which has leap years to accommodate for slight inaccuracies between the calendar and its orbit, the Julian calendar lacks these specifics. Instead, it merely has 365 day years, with a leap year every 4th year, still adding a day to February. As the Gregorian calendar was implemented at different times in different nations and places, it is important to check the history for which calendar system your date falls under. The only difference in the procedure is calculating the anchor day for a century. Unlike the Gregorian calendar, the Julian calendar actually repeats every 28 years because of its leap year rules, advancing 2 days every 4th year and 1 day for regular years. Therefore, the equation is changed to this. The original mod 4 in the parentheses is replaced with a mod 7 because of the structure of the calendar. When dealing with full centuries, it takes 7 centuries for the Julian calendar to make a full cycle, because 700 is the smallest positive multiple of 100 divisible by 28. The 5 in the beginning is replaced by a 6 because there are 25 leap years per century, and 75 normal years, so each century advances the calendar by 6 years. Lastly, Tuesday is replaced by Sunday because that happens to be the anchor day for years divisible by 7. Hope you enjoyed the video. My sources are linked here as well as in the description below. They also contain some other facts and tricks related to Conway's Doomsday algorithm.